So we know in marriages that men are typically older than women. It's just the way it is. So here we're going to investigate that. Now this is not always the case. There are some cases where the women are older than men. It just happens to be less common for whatever reason. So let's go ahead and do some statistics here. So let's create a scatter plot. I'm going to insert a scatter plot here, and I'm going to add a trend line, and I'm going to add axis titles. Woman's age. So the x-axis is the man's age. Can I select that properly? Age in age. Oh, goodness gracious, I can't type right now. Gonna click around more. Okay. So it looks like there is a decent relationship here. Despite the fact that we have a lot of variance in our ages, the relationship, most of our data points are very close to this line. All right, so that's interesting. If we knew nothing about how ages worked, I mean, we would be on the path to discovery here. So I'll create my counts for men. I'm going to do average for men. I'm going to do all these formulas first and just copy them over. So we did not measure all men in the universe. It's just a sample. Same thing with women. So we're going to use confidence.norm, 0.05 standard deviation. I've got that there, and I've got my sample size. So the lower estimate will be my average minus the confidence interval. The upper estimate will be the average plus the confidence interval. We're going to take all those values. I'm just going to copy those formulas and paste them right next door for all the women. All right, so my correlation equals correl. Array 1, I'll choose the men. Array 2 will be the women. Now I could use either. Like I could use the woman's age to predict the man's age, predict, vice versa. Does not really matter. So let's say if we want to predict, most likely if a man is 45 years old, how old is his spouse? So we can use forecast.linear. So the new x that I want to predict with is in cell B31, 45 years old. The known y's, that'll be the woman's age. The known x's will be the man's age. So I'm predicting that it's probably going to be about 43 years old, but I know it's probably not going to be exactly 43 years old. So if the man's 45, okay, so that's right here. Like how far off is that probably going to be? So I'm going to use the STE-YX. This is going to tell me, like on average, how far off are my predictions? Known y's, known x's. So I'm typically off by about 3 years. Okay, it's not too bad. And we can just looking at the data, that's not too bad. Like here I've got this woman, she's 60, the man's 58, so she's actually 2 years older. Here the man is 2 years older. We've got a bunch of different relationships here. So being off by 3 years in this instance, not too bad. So my prediction lower limit will be 43 minus that 2.98. The prediction upper limit will be that 43 plus 2.98. What does this really tell us? Well, we can be 95% confident based off of this data that if a man is 45 years old, his wife will be somewhere between 40.1 years old and 46 years old. That's the statement that we can make. So I think it's a pretty good estimate. Let's take a look at this again. So here, if we just wanted to use that forecast.linear, so we're going to pretend, so we're going to use This is a little bit off because we're using values in our data set to predict a new value that's really in our data set, but that's okay. We're just going to do this for demonstration purposes. Okay, so we want to make these known y's and known x's all absolute references because we are going to copy this down the row, and I shouldn't have done that. Should have put the parentheses after I deselected that range. Hit enter. So if a man's 30, the predicted woman's age is 27.7. Whoops. You can see the mistake I made there. I went a little bit crazy with the absolute references. That B5 should be a relative reference. Now we'll copy it down, and it should make a lot more sense. So if a man is 91, it's predicting that the wife's age is probably 90 years old. Okay, that's reasonable. And the filled a little bit too much. I want that to be the average. So how off was this error? So if I take the predicted age minus the actual age, you can see it gives me a negative number there. If I want to just look at the total error, I guess you could say, I could take the absolute value of that. So it's off by 1.3 years, either direction. I'll fill that down. I'll have to delete the last value. Delete a couple values. Son of a gun. Delete those and clear that. No fill. Okay. That was more work than it should have been. Anyway, here we are. Let's say, what if I say equals average here? What's the average of all these prediction errors? So looking at this, what does that tell us? Okay, so the average that I'm off is about 2.6, which is very close to our standard error xy. The formula for the standard error is a little bit more complex than what we've calculated here, but it's kind of in the same spirit of what we're doing, which is why I wanted to show the relationship here, rough relationship between our prediction error and the standard error. It's just that this is not quite statistically 100% accurate, but hopefully the meaning of what that standard error is demonstrated roughly through the average of this prediction error here. Okay, so there we go. Make sure to use the STEYX. That's the real way to calculate that. So, is there a strong correlation between the ages of men and women? I would say absolutely yes. The 0.992 is extremely high.